Okay, so let's do some recap on what we learned on Monday. So let me present this one. Okay, so everyone can hear my voice or not?
Yes.
Yes.
Okay, thank you. Okay, so uh, we already learned about motion in one dimension, meaning that the motions only takes place for the x, only x and y exist, but not simultaneously. Okay, so in this case, you already learned about displacement, velocities, and accelerations, and all attribute formulas such as average velocity and average acceleration together with the instantaneous velocity and instantaneous acceleration. So let's do some recap. So this is where we actually define this displacement. Okay, there's some difference between displacement and distance. So make sure you know already. Okay, so the displacement is a delta x, which means we have a final position of the xf minus with the initial position of xi. Okay, I means initial, f means final. And this is the velocity. And of course, the velocity is the total length over total time. For the average means purata. So we can define that as a total path length over the total elapsed time. And the unit as the SI unit for the velocity is of course meter per second. So this is the one examples that we are using, a turtle and a rabbit that involve the average speed. Okay, this is also uh, um, the graphical interpretation of average velocity. Okay, and this is what we call as instantaneous velocity. What does it mean? What is the difference between instantaneous and also average velocity? Okay, so this is the examples using a train that we already discussed about the average velocity and together with the instantaneous velocity. So you can actually always refer to this kind of examples in order to understand. Okay, this is some examples. One examples that involve the instantaneous velocity, but is using an equations. Okay, given to you an equations of position. Okay, where is the equation here? And the equation is x equals to, in the question, look at the question, x equals to a t square plus b, where a is 2.1 meter per second square and b is 2.8 meters. So this equation is plot to the graph. Okay, plotted to the graph, and of course we will learn something from from the equation, because x is position. When you do a differentiation to the x against time, so you can get v, because v is dx over dt. Okay, and acceleration, what does it mean by the accelerations? Okay, change in velocity, delta v, change in delta v, change in velocity, velocity final minus velocity initial over the total time, which will give you meter per second square. Okay, so acceleration increasing speed and the deceleration decreasing speed should not be confused with the directions of velocity and acceleration. Of course, well, the directions of velocity and then also the acceleration doesn't show you any kind of involving accelerations. Okay, the directions of velocity, for example, okay, will still going to the right, while we can have a acceleration or deceleration, because the acceleration and deceleration meaning that the object will only increase or decrease in speed. So deceleration occurs whenever the velocity and acceleration have opposite sign. Okay, now we move to the instantaneous acceleration. So what is the instantaneous acceleration again? Okay, when we try to do differentiation to the v, meaning that we actually can be given a v velocities in terms of maybe a graph, or maybe like we do just now, equations. Okay, equations involving v. Okay, and when we do a differentiations to the against time to the v, so we can actually get instantaneous acceleration. So again, please do make sure you will be able to differentiate between average and also instantaneous, because instantaneous normally will you will be given a time at a certain time. So we want to find what is the velocity or what is the acceleration, but definitely for the particular of times. Okay. So just now we stopped at the one-dimensional motion with a constant acceleration. So what does it mean by the constant accelerations? So when object move with a constant acceleration, the instantaneous acceleration at any point in the time interval is equal to the value of the average acceleration over the time interval. Okay, so meaning that we actually want to derive, okay, from this average as a value, meaning that from the change of the velocity against time, so we can actually obtain that, right? So we want to get to these equations. Okay, so there are a few equations here. So like this one, the number one, v equals to v naught plus at. Again, v is the final velocity, while v naught is the initial velocity, a is the acceleration, and t is time. You can also obtain v bar. What does it mean by v bar? V bar is the average velocity. See, when you do have initial velocity and the final velocity, so meaning that you do have two uh, possible velocity, two velocities, okay, initial and also final. So you add up these both values to get one average. So that's why v bar, meaning that that one is a average. Average for the two velocities, meaning that you have two velocities, you divide with two, so you can get average. So this one is quite common. Okay, but for the v, please concentrate more on the certain equations that you actually can memorize this one easily. Okay, so the number three is the delta x, meaning that there's a change in the speed, sorry, change in the displacement. Okay, delta x means displacement. So xf minus xi equivalent to half v naught plus v times t. Okay, half v naught times plus v naught half v naught plus v times t. Okay, so when this one is actually derived from the first equation, sorry, from the second equation. As you know, that v is actually x over t. So when you bring this t, look at the third equation. When you bring this t to the the other side of the equation, meaning that you can have delta x over t equivalent to half v naught plus v. So half v naught plus v is actually equivalent to the one we did on the second equation. So therefore, x over t is equivalent to v. So the same goes to the, so actually equation number two and equation number three is actually derived, and of course is actually the expanded version of extended version of the equation number two. Okay, so please concentrate more on the equation number one, number four, and number five. Okay, because that is actually where we can apply this constant acceleration equations of motions. Okay, so so let's look at the videos provided to us. So let me start from this. Moment. Okay. So we will learn the motion in another motion in one dimension, but this one, before this we learn in x-axis. Now we will learn some things that related to free fall. Free fall meaning that jatuh bebas. So definitely will involve a motion in one dimension, specifically y-axis. Okay, so please look at the video, guys.
Assalamualaikum and good day to everyone. My name is Madam Fadiatul Hasinah binti Muhammad. Today we will continue chapter 2, which is motion in one dimension. For today we will cover subunit of chapter 2, which is 2.4, free falling object. At the end of the session, students should be able to apply the kinematic equation for constant acceleration to free falling object. A freely falling object is any object moving freely under the influence of gravity alone, and it's not depends on the object's original motion. All objects falling near the Earth's surface fall with a constant acceleration. Acceleration tells you how fast the velocity changes for every second. The acceleration is called the acceleration due to gravity and indicated by the symbol of g. The value or the magnitude of g is 9.80 meter per second square, and g is always direct downward, which is toward the center of the Earth. It's conventional to define up as a positive and down as a negative. So, in this case, the gravitational acceleration is A equal to negative g equal to negative 9.8 meter per second square. Ignoring air resistance and assuming g doesn't vary with altitude over short vertical distance, free fall is constantly accelerated motion. Okay, let's do a simple experiment before we move further. A ball and a light piece of paper are dropped at the same time. Guess which one is true? A. The ball and the paper reach the floor at almost the same time. B. The ball reached the floor first before the paper. C. The paper reached the floor first before the ball. So, what's your answer? The answer will be B. The ball reached the floor first before the paper. Okay, before we look at the explanation, let's look at the experiment 2. A ball and a light piece of papers are dropped at the same time. Actually, this is same as experiment 1, but now the paper will crumple up. So, guess which one is true? So, the answer will be A. The ball and the paper reach the floor at almost the same time. Can you explain why? The greater the surface area of the paper, the greater the effect of air resistance. If you can eliminate the air resistance completely, then both objects will hit the ground exactly in the same time because they only have the influence of the same gravity, which is Earth gravity. This is another example effect of air resistance. Near the surface of the Earth, all objects experience approximately the same acceleration due to gravity. Free fall is the motion of an object subject only to the influence of gravity. In the absence of air resistance, all objects fall with the same acceleration at a given location on the Earth, and in the absence of air resistance, all objects fall with the same constant acceleration. The expression of free-falling object doesn't necessarily refer to an object dropped from rest, but it also refers to the object thrown upward or downward. For object drop, initial velocity is 0, so V0 here is initial velocity. Let up be positive, down will be negative. Generally, we use y instead of x since free fall is moved in the vertical motion. The gravitational acceleration is g equal to negative 9.8 meter per second square as g is direct downward. For object thrown downward, the initial velocity not equal to 0 as we thrown the object with the velocity. And the initial velocity will be negative because of the object is thrown downward. For object thrown upward, initial velocity is upward, so it will be positive. The instantaneous velocity at the maximum height here equal to 0 because of at this point object will stop for the moment before it turn back to the ground. The gravitational acceleration g is negative 9.8 meter per second square everywhere in the motion as g is direct downward. This is example of the symmetrical motion when time to reach the maximum is equal to the time to hit the ground or to reach the initial point. They also have a motion where it is non-symmetry or called as non-symmetrical motion. Later I will show one example on the non-symmetrical motion. If we have the non-symmetrical free fall situation, we need to divide the motion into segments. The possibilities include upward and downward portion. So this is the situation for symmetry and this is for non-symmetry. Okay, just want to recall back all the equation that you have learned in subtopic 2.3. This is all the equation I use in situation with uniform acceleration. Okay, now let's look example 2.8 taken from 11 edition survey textbook, page 50. A ball is thrown from the top of a building with an initial velocity of 20 meter per second straight upward at an initial height of 50 meter above the ground. The ball just missed the edge of the roof on its way down. Determine A. The time needed for the ball to reach its maximum height. To find the time needed for the ball to reach its maximum height, first thing you need to do is list down all the information given from the question. You have initial velocity v0 equal to 20 meter per second, y0 equal to 0, y0 is the initial position of the person, t equal to 0, t is the time just before the ball is thrown upward. Then you need to identify which equation you want to use. You can use equation V equal to V0 plus AT or AT plus V0. As you know that at maximum height, V equal to 0. By calculating this, you can find the value for time needed for the ball to reach its maximum height or T equal to 2.04 seconds. Again, you need to remember that the gravitational acceleration always equal to negative 9.8 meter per second square as gravity is downward. For B, find the maximum height. Again, at maximum height, V equal to 0. By using the equation delta y equal to y minus y0 equal to v0 t plus half a t squared. So you need to find the value of y here. So you will get the value of y maximum equal to 20.4 meter. Alright, so now look at question C. Question asks to find the time needed for the ball to return to the height from which it was thrown and the velocity of the ball at that instant. Means that question need to find t here. Okay, let's identify which equation you want to use. You can use equation delta y equal to v naught t plus half a t squared. Okay, delta y equal to 0 because of at this original position y equal to 0 minus initial position equal to 0. So by calculating this, you can find t equal to 4.08 second. Actually, there are another way to find t at this position. Because of previous, you have find t at the maximum, right? So due to this symmetrical motion, when you have t at the maximum point, you can times by 2, you will got the t at this position. So t will be 4.08 second. Okay, now look at for velocity of the ball at that instant. So you can use equation v equal to v naught plus at. Again, A is the gravitational acceleration mass equal to negative 9.8 meter per second square as gravity is always downward. So you got the negative value for velocity which is negative 20 meter per second. Negative is referring to the velocity of the ball downward. Alright, so now look at for question D, the time needed for the ball to reach the ground. So question asks to find T right here. Okay, so you can use equation delta y equal to v naught t plus half a t square. Again, we use delta y equal to negative 50 meter because of we set y is negative below the 0, meaning that this is your reference point here, y equal to 0. Anything above 0 will be positive, below 0 will be negative. So that's why your delta y will be negative 50 meter. By calculating this, you can find t equal to 5.83 second. So, last question. Question E, the velocity and position of the ball at t equal to 5 second. You can try by your own for this question, yeah? Alright. Okay, now let's look example 2. Suppose that a ball is dropped from a tower 70 meter high. How far will it have fallen after a time t equal to 1 second and t equal to 2 seconds? Please ignore air resistance. Okay, you need to list down the information given, which is a ball is dropped, meaning that initial velocity equal to 0. Height of the tower is 70 meter. Time given is 1 second and 2 seconds. Okay, then you need to identify which equation you want to use. You can use equation delta y equal to y minus y naught equal to v naught t plus half a t square. Now we do for time 1 second first. So delta y equal to 70 meter. V naught equal to 0, t just substitute with 1 second plus half a t square. Again, a equal to negative 9.8 meter per second square. Negative sign you can put here or here, doesn't matter. You still get the answer negative 4.905 meter. Then same goes to the time equal to 2 seconds. Just substitute t with the 2 second and t here with the 2 second. You can get the negative 19.62 meter. Note that all answers are negative because of the final position is below the initial position, which is downward. For summary of free fall, every object that moving upward will have the positive velocity while moving downward will have the negative velocity. The gravitational acceleration always negative 9.8 meter per second square everywhere in the motion as the gravity is direct downward. Since free fall object is about moving in one direction, we only refer to the y-axis. Thanks for watching.
Okay, so let's do let's do some recap regarding regarding the, the videos. Okay, so let me start from the first. Okay, the motion in one dimension. Okay, so this is a motion in one dimension. So how does it call this motion in one dimension? Again, motion in one dimension is because of when we deal with the problems, it only involve one axis only. Okay, it will involve one axis at one time, meaning that we don't complicate between x and y. It's just x or it's just y axis. Okay, simple as that. So that's why it's called motion in one dimensions. So let's look about motion in one dimension. The topics 2.4 is for the free falling objects. Okay, so the free falling objects again, I want to mention about the usage of the equations, right? Okay, so at the end of this, at the end of this session, so the students know how to apply the kinematics equation for constant acceleration to free falling objects. Okay, so the 2.4, the topics 2.4 specifically will discuss about the free falling objects. What does it mean by the free falling objects? Meaning that it's jatuh bebas. Okay, okay, jatuh bebas means okay, it falls with the presence of the gravitational acceleration. Okay, so it doesn't fall when people's okay going to pull from the from the bottom as for examples. So it's only depending on the gravitational acceleration, or should we call it g. Okay, so in here, so this is the free fall. A free falling object is any object moving freely under the influence of gravity alone. Okay, so the free fall does not depend on the object original motion. Okay, the free fall does not depend on the object original motion, meaning that the situation is the free fall. Okay, but according to the slides now, just now you saw in the video. Okay, what happened when the ball is being thrown upwards? Okay, dibalik ke atas. What will happen? Does it count as a free fall? The answer is yes. It's also called free fall. Okay, it's as long as the object okay involved or influenced by the gravity, so that's what we call as the free fall. Okay, so it doesn't matter whether the object is going down or going upward, as long as it move or it falls or it move with the presence of the gravity, so it's called free fall. Okay, so don't fall for the words free falls. Make sure you understand better, or you understand well what is the free fall means. Okay, because the free fall will involve gravity, right? So without gravity, we cannot say it is a free fall motions. Okay, all objects falling near the Earth's surface fall with a constant acceleration. The acceleration is called the acceleration due to gravity and indicated by g. Okay, definitely we will use g. Okay, g is 9.8 meter per second square, right? For the acceleration due to gravity. So that's why when we deal with some things that related to the equations of motions, remember that g is part of the equations. Okay, where? At A. Okay, definitely at A. All right. Anyone to ask me questions? Ada soalan so far? Sebelum kita teruskan. Anyone? Do you have a questions? Tak ada? Okay, so let's continue. Okay. Um, right. So right. So this is the free fall is symbolized by G, where the G value is 9.8 meter per second square, and G is always directed downward. Okay, so the word downward means it must directly towards the center of the earth. Maksudnya dia mesti ke arah bawah. Okay, you can. But what happened to the when the ball is thrown upward? Okay, so that's why we need to understand the concepts of free fall. Okay, when the ball is thrown, of course the ball will okay, don't get confused between motion in one dimension and two dimension, because in two dimension it will involve x and y simultaneously, but for the motion in one dimension it only involve one axis at one time. Okay, one exists at one time. So that's why when we do something with the free fall, motion must be directed towards downward. Okay, directed downward or directed upward. Okay, so all involve free fall because all will involve gravitational acceleration 9.8 meter per second square. And ignoring air resistance and assuming G doesn't vary with the altitude over short vertical distances, a free fall is constantly accelerated motion. Okay, of course, it's been accelerated. That's why you have G and you have A. Okay, right. So let's continue. Okay, so like this, madam said that G is of 9.8 meter per second square, but for A is equivalent to, A is what? A is acceleration. And of course, acceleration is a vector quantity. Therefore, when the A is going upward or A going downward will influence G. But doesn't influence G, but will influence the motions. Okay, so as A is always negative G. Okay, when the object is on the air with the presence of the gravity, definitely, okay, it will involve A. So in easy words, we can say that the acceleration is always negative G. So that's why when you put the value A, you put the value A uh, on the equations of, let's say, V equals to V naught plus AT. So you need to remember that A is actually negative G. Okay, so let me show you uh, using, okay, if you are given V equals to, okay, V equals to V naught plus AT. Okay, you may also have, okay, so this is one equations that involve this one velocity, final velocity, initial velocity, acceleration, and also time. So when does the free fall will take place? So the free fall, so this is motion, okay, motion 1D, okay, motion in one dimension. So in the free fall alone, okay, for the free fall alone, remember one thing, A is always equivalent to negative G, okay, which means A will be equivalent to negative 9.8 meter per second squared. So when you do some equations, when you use the equations, remember to put A equivalent to negative 9.8 meter per second squared. Okay, so you need to put A equals to negative 9.8 meter per second square. Again, I should remind you again and again, the gravitational acceleration, but when the people ask you what is the gravitational acceleration, G will always equivalent to 9.8 meter per second square. So don't get confused between the terms. We are now using a different terms of A and G. Okay, because A is negative 9.8 meter per second square. This one is called acceleration. And this one is the, and also acceleration due to gravity. Okay, it's actually the same thing, but this one is the general acceleration. This one is general acceleration, and this one is the acceleration due to gravity. So make sure don't get confused between the terms, because A is always equals to negative G. Okay, A is always equals to negative G whenever we have a free fall motions. Okay, so definitely it will influence V equals to V naught plus AT, for example. So if let's say you want to find, okay, so the value should be like this, V naught plus negative 9.8 T. Okay, because A is always equals to negative G for the free fall. But this only occur when you have a free fall motions, when you have a motions only in Y axis. But if you do motions in X axis, don't ever try to put G for the acceleration, because you need to calculate the acceleration. Okay, all right. So how about the questions, Charlotte? Okay, so I say, do you have a question to ask? Ada soalan tak? Okay. Ada soalan? Adam tanya, when do we know when to use negative 9.8 or a 9.8? Okay, it's either negative 9. Adam is asking when to use a equivalent to 9. Sorry, uh, not a. How to use when to use 9.8 meter per second square or negative 9.8 meter per second square. Am I right, Adam? Okay. So when to use 9.8 and when to use negative 9.8. Okay. Normally, 9.8 is always associated to uh, gravity. Remember, because A is definitely can be any values. Okay. But for G, definitely we will use 9.8. G is always 9.8. And remember, okay, uh, whenever we have a situation like, for example, if the ball is thrown upwards, okay, the word here is thrown upward, okay, this word upward means it's been thrown straight. Yes, thrown straight upward. Okay, it did mention like that. Okay, the ball is thrown uh, straight downward. The word downward, the word upward, straight. Okay, it's actually meaning that say this one will use free fall. Okay, so we can easily change from A equals to negative G. So A will be equivalent to negative 9.8 meter per second square. Am I answering to you, Adam? Okay. Anyone else? You want to ask me questions? Please.
Um, Teacher, I don't understand
Mm-hmm.
about this acceleration, gravity.
What kind of acceleration, or what kind of acceleration that you don't understand? For
About
example, soalan dia macam mana?
acceleration for gravity and acceleration for normal.
Okay, right. Okay, but first let me uh, give you few equations. Okay, so the first equation is V equals to, this is what we call as equation of motions. Okay, the equations of motions. So this one we have V equals to V naught plus AT. We also have V square equals to V naught square plus A 2A delta X. Okay, maybe we can write this one in terms of delta Y, V naught square plus 2A delta Y. Okay, you know why I use delta X or delta Y? That is depending on the axis. So, if the motion is in the x-axis, then we use delta x. But if the motion, like just now, we did on the y-axis, so we use delta y. Simple as that. Okay, and of course, delta x is equivalent to v naught t plus half a t squared. So these three equation is very important in the motion. So when you deal with the motion in one dimension, so meaning that we should establish these three equations. Of course, they have another one, which is um, delta x equals to half v plus v naught times t. Okay, we have another one, but the last one, okay, should be remembered in terms of, because it will be related to average velocity. Okay, so these three equations, okay, I should call this one as equation number one, okay, equation number two, and also equation number three. So what is the importance of these three equations? We actually can get, okay, either displacement, velocity, acceleration, or maybe we can find time. Okay, in order to understand the concepts of motion. Motion maksudnya apa? Pergerakan. So motion, to be specific for this topic, will be motion in one dimension. Okay, motion in one dimension, meaning that you have one axis at one particular time. So awak selesaikan masalah dalam satu axis pada satu masa sahaja. Maksudnya one axis. Dia tak adalah percampuran. Okay, doesn't involve x dan y pada masa yang sama. Because that's considered as two dimension equations. Okay, two dimensions of motion. Motion in two dimensions. So now we have three equations. Okay. So soalan tadi tanya dia tak faham macam mana nak selesaikan macam mana soalan dia tadi, acceleration. Boleh saya dengar balik soalan dia? Farhad?
Lupa apa tadi. Yang
Mana nak tahu acceleration ke apa benda?
macam mana nak guna untuk soalan macam untuk gravity dan yang bukan gravity.
Maksudnya okay, alright. Okay. Okay, so like I said, okay, macam Farhad tanya tadi, macam mana nak guna acceleration, sama ada acceleration ke, sama ada A ataupun maybe G. Bila masa nak guna. Okay, ingat A sesuai untuk X axis and Y axis. G dia ialah duduk di sini, Y axis. Okay, maksudnya A kita boleh pakai, maksudnya equation yang atas tadi. Okay, this equation, okay, number one, semua ada A. Kalau kamu tengok dekat sini semua ada A. Okay, you have A, you have A, and you have A over here. So dekat tempat A itulah yang kita akan ganti dengan negatif 9.8 bila masa berlaku beberapa terms. Macam contohnya saya cakap tadi, okay, you have a ball is thrown straight upward. Tu ayat dia. Ball is thrown straight upward. Ball dibaling, artinya bola dibaling straight ke atas ataupun straight downward. Maksudnya okay, soalan contoh kita lepaskan bola dan bola jatuh ke bawah. Straight downward. So itu adalah salah satu ayat yang kita boleh detect daripada soalan yang menunjukkan kita perlu pakai free fall. Maknanya kita perlu pakai Y axis instead of X axis yang normal. Okay. Sebab nanti dalam next chapter we will learn motion in 2 dimension. So there will be a confusion between when to use the motion in 1 dimension or maybe motion in 2 dimension. So definitely motion in 2 dimension nanti kita akan expandkan equation 3 ni kepada 6. Maksud dia 1 dalam X, 1 dalam Y. So itu je beza dia, motion in 1 dimension and 2 dimension ni. Okay. So untuk soalan Farhad tadi, when to use A, again saya mention A is always relevant to any equations. Tetapi A, kalau dalam situation X biasa, in a normal situation X, okay, maksudnya pergerakan yang contohnya macam cerita pasal rabbit hari itulah. Ingat tak cerita pasal rabbit dengan turtle tu? Okay, dia lari-lari, so itu kita akan pakai A yang biasalah. Maksudnya A sama ada kita calculate daripada soalan ataupun we get from the sama ada kita calculate untuk final answer ataupun kita calculate dalam given by the questions. Okay, so maksudnya nilai A tu it can be any value, bukannya 9.8. But when to use a 9.8 ni, bila ada benda-benda ni lah, bila kita boleh consider punya A ni bila dalam free fall dia akan jadi negative 9.8 meter per second square. Okay, so bila dalam situation dia berlaku free fall, bila masa berlaku free fall, remember these things. Okay, ni ada terms ni, straight downward, straight upward. So these are the key words for when to use A as a negative 9.8 meter per second. So yang kalau dalam situation ni, kita tak payah pedulilah. Maksudnya, apa nak cari A tu tak payah. Sebab A tu memang negative 9.8. Okay, it's definitely negative 9.8 meter per second square. It cannot be any value. Okay, because that's why we call it as a free fall. Okay, meaning that it falls, it moves with the presence of the gravity. Okay, now I have questions from Fik. So we if thrown upwards, so the G is negative or positive. Okay, remember these things. Okay, don't bother about the G. Don't bother about the G, because G is always 9.8. Remember, okay, G is always 9.8 meter per second square. Okay, value of G is always 9.8. What we should understand, A is always negative 9.8 meter per second square because A is equivalent to negative G. Boleh faham Jangan, sebab tu saya jangan confuse. Okay, G nilai dia memang akan 9.8. Okay, 9.8. Tetapi A ialah negatif 9.8. So, for the question for Afiq Nazmi, if thrown upward, so the G will be negative or positive. Definitely G will be same value, 9.8. Sebab tu saya tak sebut G, saya sebut A. Okay, I need to emphasize the word, the correct term is when we use, actually kita nak pakai equation mana? Kita nak pakai 3 equation ni sahaja. So 3 equation ni ada G ke tak ada? Ada G tak? Soalan saya. Tak ada kan? Hanya ada A. Sebab A ialah apa? A ialah negatif G. So bila dia thrown upward, definitely dekat tempat A tu terus jadi negatif 9.8. Terus jadi negatif 9.8. Terus jadi negatif 9.8. Sama juga bila ball tu tengah turun. Bila ball tu tengah turun, dia pun pakai negatif 9.8, negatif 9.8 juga. Tidak ada masalah. Because it doesn't influence by the motions. So motion dekat atas atau motion dekat bawah, the value will still be negative 9.8 for the acceleration. For the acceleration. Because gravity is always 9.8 meter per second. Ingat, gravity dia tak kisah. Awak balik ke atas, awak turun ke bawah, gravity masih sama. Okay, gravity masih 9.8. Awak balik daripada bawah, daripada atas, okay, balik ke celah mana pun, mesti 9.8. Tetapi acceleration, so kenapa saya mention acceleration? Because we want to use that acceleration, okay, in the equation. Okay, is still negative 9.8 meter per second square. Okay, am I answering you, Afiq Nazmi? Cool. Okay. Ada soalan? Sebelum kita teruskan dengan kita punya okay, maybe we should take a break for 2 minutes. Okay, maybe awak nak pergi toilet ke apa ke, boleh dulu. Before we continue with the examples. Okay, so let's continue our lessons on the examples. So let's look back. So this is the simple examples using a simple experiment using a ball and a light piece of paper that drop at the same time. So the answer is the ball reached the floor first before the paper. So why? Because due to the air resistance. Okay, because the paper will the surface area of the paper is much more bigger when compared to the ball. So that's why the paper will be influenced by the air resistance. So therefore, the paper will not meet the times as the ball reach the floor. Okay, so the ball will reach the floor first before with compared to the paper. But if we crumple the paper, what happened? Okay, when you crumple the paper, so meaning that the surface area of the paper have already been decreased. Okay, and of course the same. We look at the size of the crumpled paper is actually the same as the size of the ball, and therefore we can say that the ball and the paper reach the floor at almost the same time. At almost the same time. Okay. So this is the experiment is want to show you that the surface area of the surface area of the object will actually influence the air resistance, and the air resistance will influence the free fall. Okay, the motion in the one dimension, of course, is being related to the gravity. Okay, the gravity involved, and that's why when we try to do it in the okay, we try to do it in the vacuum. Okay, the vacuum with no okay the situation where we don't have a when we have a vacuum situation, meaning that one tube has been filled with air, another tube evacuated tube. Evacuated tube means that we suck out all the air inside the tube, so we can say that the tube is actually vacuum. So that's why we can look at that particular object. Okay, where the feather and the rock, or maybe the feather and the objects, okay, is actually fall at the same time. Okay, because there is no air resistance in the evacuated tube, and the objects falls at the same acceleration. So that's why are saying that okay, when there is no air resistance, meaning that okay it doesn't all objects, okay, regardless of the surface area, okay, regardless of the shapes, okay, will fall at the same time. Okay, but not comparing. If the objects is the feather, maybe with the bigger ball, okay, cannot say like that. Okay, of course the bigger ball will fall. Okay, uh, but this is the case where the object is actually have a similar size and falls under the evacuated tube. So okay, we can say that in the absence of the air resistance, all objects fall with the same acceleration. This acceleration is called gravitational acceleration. Okay, so we are saying this is G. Okay, so the initial velocity, so meaning if the object drop, okay, when you have a situation where the object is dropped, and of course it dropped. Okay, when the mention drop is not okay, it actually doesn't show anything yet. But if the object is being dropped directly towards, or maybe they will put drop straight downward, drop downward, or any kind of word that meaning that if been straight, okay, it drops straight downward. Okay, so that will fall under free fall motions. Okay, because when the object drop, maybe okay, there will be times that it been um, disturbed by the error system. So the error system will actually uh, push, okay, the object into the another axis. Okay, so in this case, when the object drop straight downward, we can confirm that the object is actually dropped in y-axis. Okay, so in y-axis and only y-axis, so it doesn't involve x-axis. So that's why in the kinematic motion, we can use y instead of x. Okay, so because there is no distance from the x-axis. But if the question doesn't say anything related to the anything that related to straight downward, so you cannot say that it's all free fall motions. Okay, so make sure that you read the questions carefully. Make sure you do understand the questions properly. Okay, take out all the good point, the good informations in the questions. Okay, maybe you can underline, you can circle, you can highlight it in order for you to understand well. Okay, so let up be the positive. Okay, so the acceleration here. Okay, I think there's some mistakes over the figure. The figure should be a equivalent to negative g. Okay, a equals to negative g, because g is actually negative. A equivalent to negative g. So a is negative 9.8 meter per second square. Okay, so as I said to you, with the upward being positive, initial velocity will be negative. So, what the difference between this figure and of course uh, this one? Okay, an object thrown downward. Okay, thrown downward meaning that you have a negative velocities. Okay, and the acceleration is still negative g. Acceleration is still negative g, meaning that as a is equivalent to negative 9.8 meter per second square. Okay, so let's straight away go to the equations. Okay, this one not equation yet, but this one is a free fall for the object that have been thrown upward. Okay, thrown upward, dibalik ke atas. Okay, ada lagi satu. Okay, so initial velocity is upward. Okay, when initial velocity is upward, so it should be positive value, meaning that the initial velocity will given in the questions should be positive. The instantaneous velocity at the maximum height is 0. Okay, meaning that when the object is being thrown upward, so definitely the object will comes down due to the gravity. So in this case, we should use a equals to again, okay, again and again negative g, which is equivalent to negative g should be negative. Okay, a equivalent to the negative g, which equivalent to negative 9.8 meter per second square. There's some typo mistakes over there. It should be a equivalent to negative g. Okay, so the motion may be symmetrical or maybe not symmetrical. For the motion that be symmetrical means it, when it go up, it be thrown upward and it comes back to the original height. It comes back to the original height. That means, okay, the motion will be symmetrical. Okay, but when the motion, of course, it only involve when you call it when we throw the rock or maybe the ball, okay, at the level, uh, what should I call this? Not on the buildings, okay. When the object is being thrown, not on the buildings, maybe at the floor, maybe at the ground level. So the ball it actually can go straight upward and comes back to the original position. So that is called symmetrical. What is the significance of the symmetrical motion? Meaning that the time when it goes up and down should be equal. Okay, the time is to go to the maximum height and then come back to the original position is equivalent to each other. Okay, but not for the unsymmetrical or the not symmetrical motion. So we can actually we may have to find another times. Okay, so let's use this one equation. So for this non-symmetrical, so as this madam said that the symmetrical will take place only on the first part. Okay, the first part meaning that you can okay look at the persons who throw the ball upward. Okay, he throw the balls meaning that the ball leave, okay, on his hand at time t equals to 0. Y not equals to 0, meaning that we should at first, okay, set the height of the, maybe at this height. Okay, we want to call this height as a main reference point where the y naught equivalent to 0. So as the madam said that when it goes upward, okay, it goes above the y naught, so it should be positive, and goes beyond the y naught, so it should be negative, or it goes below the y naught, it should be negative. Okay, so it leave the people's hand, this man, at 20 meter per second. So that should be the V naught. Okay, okay. So when the ball reach the maximum height, definitely at maximum height, what is important is V. Okay, the final velocity should be equivalent to 0. So that's why when you try to calculate the time taken for the ball to reach its maximum height, so make sure you put the v equals to 0, and of course you can add, you can find another term. So when you have a t, so you can maybe use that t to the next equations so that you can get 20.4 meters. Okay, and it goes back to the original positions, but of course the ball is being thrown, okay, move, okay, past the edge of this hand. Of course dia tak sabut balik, and of course ball tu akan terus jatuh ke bawah, and that jatuh ke bawah tu is considered not symmetrical motions. So we need to find another time. For example, you can see the original time is time t equals to 0. When it goes up, it becomes 2.04 seconds. Okay, it comes back to the same height as the hand is 4.08. 4.08 second is actually double the times we need to go to the maximum height. And of course, when it goes down, this from 4.08 now, you can see the time is increased to 5 seconds, 5.83 seconds at the ground floor of the buildings. Okay, so this height, okay, have been added. Obviously the building doesn't show the height of the building is not 50 meters. The 50 meters is the height of the building together with the height of the heads. Okay, so you must add the height of the building and the hands, and of course you can get 50 meters. And at the belows we can get c. Okay, at time v final velocity. Okay, at the top of the maximum height, the final velocity 0, and you can see when the final velocity on the way down is always already become negative value. Okay, uh, okay, the final velocity on the way down will become negative value, negative 20, negative 29, negative 37. And of course, y here, y max is 20.4 meters, and at the same height as the hand is y equals to 0, and below that y becomes y equals to negative 22.5, and lastly, okay, at the ground floor y is becomes negative 50. So that will give you, so of course the main point the main idea to get this kind of value, you must first get what is the time taken. The time is very important to tell everything about velocity, everything about displacement, and of course everything about final velocities. Okay, so please remember this thing. So let me do. Okay, so everybody please take a snap photo of these questions. Okay, boleh tak? Snap dulu gambar ni dan saya akan terangkan dalam penerangan sekejap lagi. Boleh ya? Dah snap? Okay, so let me stop here then try to explain to you. Okay, so let's see. Okay, so if the man, okay, the ball is thrown, okay, the question asks you a ball is thrown from the top of a building with an initial velocity, okay, v naught equals to initial velocity 20 meter per second, straight upward. Look at the words used in the question, straight upward. So this is the indicator of this one should fall under the free fall motion. Okay, at an initial, oh sorry, can you see it? Okay, good. Okay, under the free fall motions. So at an initial height of 50 meters, okay, 50 meters is just, the value is 50 meters. So let me, okay, the original height is 50 meters. Okay, so meaning that we should set. Ada orang dia akan set maybe kosong dekat bawah ni, 50 dekat atas ni. Okay, satu orang. Ada orang di sini set, masa dia baling, dia nak set kosong dekat sini. So dekat bawah ni jadi berapa? Kelas? Kalau dia set kosong dekat level ni, dekat bawah ni jadi berapa?
Negative 50.
Negative 50.
Yes, jadi negative 50. So this all depends on how you take the reference point. Okay, so let's say kalau kamu ambil 50 dekat atas, maksudnya kat bawah jadi kosong. Kita tak kisah macam mana pun. Yang penting kita faham macam mana dia solvekan problem ni. Okay, the question ask you, so kita ikut macam mana dia suruh lah. Maksud tadi dia set 0 and of course at below it becomes negative 50. Okay, the ball just misses the edge of the roof. So maksudnya dia akan baling ke atas. At one point, it reach the maximum and go straight. Okay, sampai bawah ni. So dekat atas ni dia akan jadi one time, dia akan jadi, this is maximum height. Okay, so soalan yang pertama, tengok soalan dia tanya, determine the time. Dia mesti cerita pasal time. Kenapa? Always cerita pasal time. Okay, time needed for the ball to reach the maximum height. Okay, to reach the maximum height, so equation mana kita nak pakai? Tadi kita dah ada a few equation dekat sini. So kita tengok yang involve time sama ada nombor 1 ataupun nombor 3 je. So which one yang lebih sesuai? Okay, so saya tengok dekat sini maybe, okay, maybe kita boleh pakai equations yang kedua atau yang ketiga. Okay, it all depends on you. You nak pakai equation mana? Okay, so yang penting kita ada beberapa equation dekat situ. Macam saya cakap tadi, kita ada equation V equals to V0 plus AT. Yang penting sekali, equation kedua tak boleh pakai. Kenapa equation kedua tak boleh pakai? Sebab dia
No
tak ada.
T. No T.
Yes, definitely dia tak ada time. Bila tak ada time, buat apa sedangkan kita nak cari time. So kita kena ada cari equation yang ada maklumat yang paling lengkap. Okay, untuk kita dapatkan T. So in this case, we should use equation number 1 because V equals to V naught plus AT. Okay, right. So yang kita nak dapatkan time, of course nak dapatkan time. Okay, ingat at maximum height, the final velocity should be 0. Okay, so macam ni kita buat. So V equals to this one becomes 0. So dia akan jadi 0 equivalent to V0 plus AT. Okay. Right. T is equivalent to negative V0 over A. Negative V0 over A sebab kita bawa ke sebelah sana. And therefore T is equivalent to negative apa tadi? 20 meter per second. Saya tak letak tu. Bahagikan dengan A. A berapa? Negatif 9.8. Okay. And dapatlah jawapan dia 2.04. Okay. 2.04 seconds. Tengok cara kira. Tengok macam mana saya solvekan dia. Mesti start dengan equation. Mesti start dengan equation. Jangan terus tekan calculator. Saya faham ada orang dia nak shortcut. Okay. Ada orang dia suka shortcut. Kita shortcut lah. Kita dah faham dah. T, dia tu 20 bagi 9.8. Kan? Ni dia betul-betul. So kalau buat shortcut macam tu, kamu tidak belajar. Kamu tidak faham. Bila bagi soalan yang lebih kompleks, kamu jadi confused nak jawab. So that's why. Okay, jadi 2.4 seconds. So that is the time needed, okay, for the ball to reach its maximum height. Okay. Number 2 is what the maximum height. Okay, that determine the maximum height, meaning that determine the final position for the maximum height. Siapa yang buka ni? Saya bunyi bising ah. Syahrin. Okay. Now, determine the maximum height. So what is maximum height? Again, kita ada a few equation. Equation ni tak perlu dah kamu terujuk-rujuk. Selalu ingat dalam kepala because it give you a big advantage if you can memorize all these 3 equations. Okay, supaya you tahu, okay, aku nak pakai apa aku tahu. Okay, these 3 equations, okay, satu soalan maybe kadang-kadang tak boleh nak selesaikan. Satu equation tak boleh selesaikan satu soalan. So maybe dia kena pakai 2 equations. Okay, so that's all depends on the equation. So let's say you want to find the maximum height. Okay, apa ni maximum height? Maximum height ialah y. Okay, in this case y. Jadi kita nak pakai yang mana? Okay, so equation ni tadi kita boleh pakai juga ni. Okay, sebab ada time, ada A, ada V0. So maybe kita boleh pakai delta y. Delta y equals to V0 t plus with half AT squared. Ada sikit panjang. Okay, so delta y. So y ialah apa tadi? What is V0? V0 is 20 times with 2.04 plus dengan half negative 9.8 kali dengan 2.04 sec square. So the answer is equivalent to 20.4 meters. Okay, that's how they got the maximum height. Again, saya boleh pakai equation ni. Okay. So So mana-mana equations, as long as jawapan ni masih relevant, betul, kita akan gunakan. Okay, now we move to next part, which means kita dah selesaikan C. Benar soalan C tadi? The time needed, okay, the time needed for the ball to return to its height, to return to the height from which it was thrown, and the velocity of the ball at that instant. Okay, kalau kamu tengok macam mana dia solvekan problem ni one by one, kamu akan faham macam mana penggunaan dia. Okay, so selalu tu nak tahu time needed for the ball to return to its original position. Mana? Okay, maksudnya tadi dia naik sini 2.4 seconds dan dia turun balik. Dekat point ni lah dia nak 2.04 seconds. So kita boleh je buat time is equivalent to 2.04 seconds times 2 equivalent to 4.08 seconds. Tetapi kalau kita nak guna cara lain, maksudnya kita boleh guna juga, right, y equals to v not t plus with half a t squared delta y tadi ya. So delta y tadi kita katakan y itu jadi kosong lah, sebab dia mula dekat kosong, dia akhir dekat kosong. So delta y dari z 0, kosong equivalent to, ini satu cara, v0 ialah 20 times with 4.08 seconds, 4.08 seconds for t, time needed, sorry. Okay, biarkan dalam t tambah dengan half a negatif 9.8 kali t square. Macam ni maksudnya kita kena cari t dalam quadratic function. So nanti kita akan dapat t equivalent to beberapa value. Yang penting kita ambil value yang positif, 4.08 seconds. Boleh selesai juga. Tapi yang cara yang pertama tadi, yang kali 2 tu hanya boleh untuk keadaan symmetrical. Only for symmetrical. Okay, not that, not for not symmetrical. Okay, but only for symmetrical. T equals to 4.08 second. Okay. So the time needed, it was thrown and the velocity of the ball at that instant. Okay, maksudnya pada masa ni apa velocity dia? So V equals to V0 plus AT. Okay, yang kita nak cari ialah yang ini, V0 dan V. So V0 dia ialah 20 sama kali dengan 4 plus dengan negatif 9.8 kali dengan 4.08. So dapatlah negative 20 meter per second square. Sorry, negative 20. Okay, so soalan selesai, soalan C. Okay, soalan D, the time needed for the ball to reach the ground. Okay, dan dia time needed reach ground. Where is ground? Ground duduk dekat mana? Okay, the most important thing is you need to know where is your reference point. Reference point awak duduk kat mana? Tadi y not dekat sini. So y dekat ujung ni. Sekarang ni lah soalan ni. Sebab y ialah final position, y not ialah initial position. So initial dia duduk dekat y not, final dia dekat ni. Maksudnya 1, 0, satu lagi 5, 50. Okay, so the time needed for the ball to reach the ground. Okay, and how you may do that. Okay, so please use the third equation again, because the third equation is most powerful equations. So you have delta y equals to v naught t plus half AT square. You need to find what is T first. Okay, tapi kita tak tahu delta Y. Ingat, delta Y tu ialah apa? Y tolak Y naught equals to V dot T plus half AT square. Tengok saya tulis satu-satu. Okay, saya tak skip pun. So Y ialah apa? Y ialah negatif 50 tolak dengan kosong sama dengan V naught ialah 20 kali dengan T plus dengan half negatif 9.8 T square. Okay, dapatkan nilai T. So ada dua nilai T nanti sebab dia ialah kuadratik ya. So nilai T yang positif kita ambil 5.83 second. Selesai untuk jawapan soalan D. Okay. And the final part is Madam tu suruh kita buat sendiri ya. The velocity and the positions of the ball at time t equals to 5 seconds. Okay. Soalan dia, the velocity and the position. Okay, and the position and the positions. Okay, of the ball at time t equals to 5. T equals to 5 maksud dia kita tak tahu lagi. Okay, maksud dia tak jatuh bawah lagi. Tapi dia berapa nilai velocity dia, berapa nilai position dia masa tu. Okay, so how to do that? So first you can get the velocity at time t equals to 0. Therefore you can put velocity equivalent to V naught. Nampak lagi ke? Sekarang nampak lagi?
Nampak.
Saya ada terkeluar tu. Okay. Okay. So soalan E is to define okay, the velocity and the position. Okay. So dekat velocity kita boleh equivalent V equals to V naught plus AT. Ni saya padam dululah Y tu. Rambutlah. Okay. So nak cari at time 5 seconds. Okay. So what is V? So V ialah V naught 20 campur dengan negatif 9.8 kali dengan 5 second. So you tekan kalkulator akan dapat 20 tambah dengan negatif 9.8 kali 5. So jawapan dia negatif 29 meter per second. Don't forget about unit. Okay, unit kalau tak bubuh salah jawapan walaupun betul tapi boleh jadi salah. Okay, and then kita cari what is final position. Okay, position at time t equals to 5. So masukkanlah, you have delta y equals to v naught t plus half a t square. Apa yang buat? 25 plus half negative 9.85 square. Okay, 5 square. So masuklah dalam equations and you boleh calculate. So lebih kurang 100 tambah dengan 4.9 kali so dapat lebih kurang negatif 22.5 meter. Okay, So now you complete all the questions. Macam tu cara dia. Okay? Ada apa-apa nak tanya soalan? Apa nak tanya? That's how you solve the free fall motions. Okay?
Sir,
Yes.
ada soalan.
Yes.
Kenapa
Yeah.
A dan B, question A dengan C kan dia suruh cari time kan? Kenapa
Okay.
guna equation yang berbeza?
Yang mana?
Soalan
A dengan
A
C.
dan soalan C. Dia kan suruh cari time, tapi kenapa guna equation yang lain-lain?
Masa question A, saya memang confirm yang dia pergi ke maximum height. Maximum height, kita boleh letak V equals to 0. V, final velocity. Final velocity ni memang equals to 0. So kita boleh pakai equation yang pertama. Tapi kalau pada masa C, dia nak suruh cari apa? Time dia dekat pada masa dekat bawah kan. Maksudnya pada masa dekat bawah, dia bukan maximum height dekat situ. Faham? Dia pada masa nanti saya tandakan. Okey. Kalau warna biru ni ialah maximum height. Kat situ confirm V equals to 0 kat sini. Sini confirm bukan V equals to 0. Tapi yang soalan C, dia nak tahu dekat kawasan warna merah. So dekat sini. V dia kita nak cari. Okay, so time dekat sini tak sama dengan time dekat V equals to sini, tak sama. It's not the same. That's why saya gunakan cara yang kedua. Saya tak boleh gunakan V equals to V0 plus 80. Tak sesuai. Sebab bila guna V equals to V0 plus 80, okay, kita tak tahu V. Dan kita tak tahu T. Masalah lah kan? Ada dua benda, parameter yang kita tak tahu. So that's why we need to gunakan cara C tu. Okay, kena gunakan cara ini untuk dapatkan time. Tapi ada cara lain lah, sebab since dia ialah symmetrical, we can times 2 original time. Kan, original time 2.04 kali dengan 2 dapat 4.08. Senang. But ini situation untuk symmetrical sahaja. Okay, symmetrical maknanya dia naik dan dia jatuh pada level yang sama. Boleh ya? Aziz?
Boleh. Faham. Thank you.
Okay. Okay, lagi soalan? Ada soalan lain? It's very good examples because they involve banyak equation. Very good. Okay. So dalam bila situation ini, kebiasaannya kita boleh make sure whenever we want to use these three equations, make sure it have constant acceleration in it. Okay, this one specific for constant acceleration. What does it mean by constant acceleration? Meaning that acceleration dia hanya ada satu value. Macam tadi kan kita pakai 9.8, 9.8. Ni constant acceleration lah. Okay. Dia tak berubah. Maksud dia awal, akhir, di tengah-tengah, apa yang ketika berlaku, semuanya memang 9.8. Ataupun kalau masa dalam X, semuanya 10, semuanya 4, semuanya 5. Dia tak ada awal-awal dia 2, tiba-tiba di tengah-tengah jadi 3, lepas tu akhir dia jadi negatif 8. Dia tak macam tu. So that's why we can use a constant acceleration concept ni. So that's why you need to remember these things. Make sure you do understand the constant acceleration concept. Okay. And of course, the rest of the questions you can do on your own. Okay, it's just that kalau ada benda yang nak di highlightkan. So now we will end the chapter 2. Chapter 2 habis dekat sini. Okay, because the next week we'll continue in chapter 4. Sorry, chapter 3. Okay, chapter 3. Part of the chapter 3. Itu kita dah masuk kan chapter 3. Tapi chapter 3 yang kita discuss last week is only on the vector. We only discuss about vector. Right now, we want to know the motion in 2 dimensions. So next week, the motion in 2 dimension. Okay. But right now, ada siapa ada masalah lagi tak untuk faham? Okay. Motion in 1 dimension, specifically for free fall. Okay. Ataupun untuk kalau nak tanya yang previous lesson, because we still have time. Okay. Kalau kamu ada benda nak di-highlightkan. Ada tak? Tak ada ya?
No.
Okay. I think everybody dah faham tu. Okay, cuma jangan confuse. Saya paling risau kamu confuse antara acceleration dengan G. G nilai dia 9.8. Always 9.8. Okay, G dia. Tapi A dia akan ikut keadaan. Maksudnya A dia akan kalau dalam free fall dia memang A equals to negative G saja. Dia tak ada nilai lain. Okay. Adalah situasi nilai lain tapi jarang berlaku di peringkat kamu. Contoh dia biasanya kita punya Cartesian coordinates yang kita assume all this y is like this. Okay. This is the Cartesian coordinates yang kita selalu anggap kosong. So 1, 2, 3 macam biasa. Yang kalau y pula 1, 2, 1, 2, 3. Yang bawah pula negatif 1, negatif 2, negatif 3. Masa ni kita pakai macam biasa. A equals to negative G. Macam bila situation dia A equals to G saja, dia akan jadi macam ni. Ni Cartesian coordinate kosong 1, 2, 3 ni biasa. Yang Y dia kira macam mana? Dia pelik sikit. Dia pelik 1, 2, 3, 4. Negatif 1, negatif 2, negatif 3 dan seterusnya. Nampak? Dua situation yang berlainan. So yang ni A dia equals to G. Ini A equals to negative G. Yang ni A equals to G. So kenapa? Macam apa beza dia ni? Tengok nombor ni. Kita biasanya negatif bawah kosong kan? Dia duduk lain. Dia kosong dekat sini. Bawah pada kosong dia 1, 2, 3 dia ke bawah. Yang ni dia ke atas. So sebab tu saya kata kita pakai ni normal yang biasa, which is A equals to negative G. We just put the A equals to negative 9.8 ke dalam equations. Okay? So hopefully everyone understood these topics. Make sure you do revisions. And inshallah tomorrow I will give you some some questions. Kamu jawab klik je. Jawab ABC. Senang je dalam satu maybe 1 until 5 questions regarding our topic today. Okay, so nak tahu awak faham ke tak faham So nanti kamu boleh jawab dekat situ lah. Saya akan bagi link kepada soalan tersebut. Okay. So thank you very much for your attention. So I think we will stop our class here. If you do have a problem, then use the U-Future. Masuk U-Future, masuk dekat forum tu, tanyalah apa-apa nak tanya saya. Okay. Because kat situ kamu boleh tampal, katalah kamu dah buat workings, certain workings, then you can paste that kat your future kat forum tu boleh tanya, sir, what is my problem? Okay, yeah, I already did the calculations, but I cannot find the answer, final answers. Okay, so thank you everyone for your attention again.